We're now going to discuss a chain rule involving exponential and logarithmic functions. Here, we are expected that our students should be able to uh, perform, okay, finding the derivatives of exponential and logarithmic functions, and with the use of chain rule, right? And for us to proceed, we have, let's have these examples, okay? And these are just the simple, okay, simple simple logarithmic, exponential, and natural logarithmic functions. And on the other side, which is the right side of the figure, we have the more complex um, functions about the exponential and natural and logarithmic functions. Okay, so here we can differentiate this without using chain rule. And the other side, we need, these are the functions that we should be applying chain rule to find their derivatives. Okay, so first we need to review the formula on how to differentiate the given functions, either exponential, logarithmic, and natural logarithmic. So these are the rules, all right? This is the original rule in finding the derivative of the functions. Okay, here, this is for the exponential where the base is e, and this is for the where the base is any real number. And of course, in relation to the conditions for the exponential and natural logarithmic functions, and also for the logarithmic and natural logarithm, and for the logarithmic functions. Now, actually, we are also using chain rule here by applying or adding. Okay, let me just write it down by adding the derivative of x here. However, since the derivative of x is 1, we don't put it anymore in the given equation. But again, there must be an x prime here, which is equal to 1. So as I said in my previous video, that in original rule for the basic functions like this, now we are also using or applying chain rule, all right? And here we are also applying chain rule here, where the derivative of x is equal to 1, here as well, and here as well. However, if we consider x, or yeah, x as a function of another variable, then that's the time that we should do this. Okay? Or as I've said, these are just equal to 1. That's why it will end up to this functions or answers for the derivative of this kind of functions. And with the use of chain rule, actually these are just equal to this. So instead of using x prime, now we can use du over dx, where u is a function of x. Okay, so u here, the x was changed to u, and here we go. That's why we have du here. So whichever method you use, they're just the same. Okay, so again, to refresh, for exponential, the derivative of eu, or e raised to u, is equal to e raised to u times the derivative of u. And the derivative of b raised to u is equal to b raised to u times the natural logarithm of b times du. So it's just like the du is converted, sorry, the x prime is converted to du, as well as here, here, and here. Okay, so that's why you should not be confused on how to deal with this. Okay, applying chain rules in finding the derivatives of the exponential and logarithmic functions. Okay, so for us to see how it's going on now, or how it is being performed, now let's solve example number 1. So here, again, let's just do a recap. So we know that when y is equal to e raised to x, y prime is equal to e raised to x times x prime. All right, although this is just equal to e raised to x. But again, this is very important. When the given function has exponent of another function. So it's just like a composite function as well. Okay, as we discussed that in our videos, part 1 and part 2. So let's copy e raised to tangent 2x. Okay, let me change the color of my pen. There we go. All right, so let's take the derivative of y. So here, since it is an exponential function with a base e, so we're going to use this formula. We just copy the given tangent to x, and we need to differentiate. As you can see here, there's x prime, which means the exponent should be differentiated. So that's tangent to x prime. All right, so let's do the next step. So copy 2x. And what's the derivative of tangent? The derivative of tangent is secant square 2x. However, the x here is still in a form of another function. So this is 2x prime. All right, so this becomes e raised to tangent 2x times secant square 2x times the derivative of 2x is x, is 2. So this becomes, so we should separate this here. This becomes 2e raised to tangent 2x times secant square 2x. By the way, guys, make sure that you properly write all of the factors on their places, because sometimes we might mistakenly regard one factor to another factor, just like this. If there's no parentheses or there are no parentheses or brackets here, now we might multiply 2 to 2x here, okay? However, 2 is the coefficient of this expression, not a multiplier of an angle of secant, all right? So this is now our final answer. Okay, so that's y prime. Now let's try solving it without doing this. Let's do it directly, okay? So the problem is y is equal to e raised to tangent 2x. So how do we do that? The first thing that we need to do is, of course, we should memorize or familiarize the okay the rules for differentiating exponential. So we have e. It should be memorized or familiarized by heart. All right. So we have e raised to tangent 2x. And let's differentiate tangent to x. So the derivative of tangent to x is secant square 2x. Since we have 2x here, so differentiate 2x, that's 2. So we have 2 e raised to tangent 2x secant square 2x. Final answer. So that's how we differentiate functions like this. Okay. Now you can do the method 1. This is our method 2. This is the direct way of solving. And you can use this method 1, all right, if you're starting to deal with this kind of differentiation of functions like exponential, okay, to make it more systematic in dealing. However, if you're already used to it, then you can go to our method 2. All right. So we got the same answer, 2 times e tan 2x secant square 2x. Okay, so let's deal with example number 2. This is an exponential with a base 10, not e. So how do we do this? This is equal to a raised to x. And how do we differentiate this? We have y is equal to y is equal to a raised to x, ln a, x prime, right? Something like that. Okay, so let's apply this rule in solving example number 2. Okay, here we go. So let's solve. Let's copy y is equal to 10, 5 raised to 5x minus 2. So y prime, this is our method 1, is equal to here. So we just need to copy 10 raised to 5x minus 2 natural logarithm of 10 times the derivative of 5x minus 2 prime. Okay, so we're not doing it directly as we could. And we can now simplify. So 10 raised to 5x minus 2 times ln 10 times, so the derivative of this is 5. So we have 5 times 10 raised to 5x minus 2 times ln 10. Okay, this is y prime. Understood, guys? So let's have method 2. Method 2, the given is y is equal to 10 raised to 5x minus 2. So let's differentiate this. We have copy the given, multiply it by the logarithm of the base, natural logarithm of the base, and of course, differentiate the exponent, that's 5. So here we go. 10 raised to 5x minus 2 times the natural logarithm of 10, y prime. Okay, so we have the same answer. And again, whichever method you use, that's fine. Or if you want, we could use the U. Okay, method 3. Let's use the U, method 3. So y is equal to 10u, and u is equal to 5x minus 2. So this becomes what? So how do we differentiate y? So y prime is equal to, how do we do that? U ln 10 times u prime, right? And our u prime here, u prime is equal to 5, 5. 5 minus 0 is just equal to 5. So therefore, y prime is equal to u is equal to 5x minus 2. Oh, sorry. Sorry, this is supposed to be 10u. 10u, yeah. All right, here we go. So 10, and what is u? That's 5x minus 2, ln 10, and the derivative of u is equal to 5, so this is 5. And this is equal to 5 times 10 raised to 5x minus 2, ln 10. So we have the same answer, okay? So again, it doesn't really matter what method you use as long as you're not violating any rule in mathematical properties or rules specifically, okay? So let's have number 3. And we knew when y is equal to ln x, this is y is equal to 1 over x times the derivative of x, all right? So we have copy y is equal to the natural logarithm of x cubed plus 1, and y prime is equal to what? This becomes 1 over, we're going to put it on the denominator, that's x cubed plus 1, and we differentiate this, okay, prime, this is equal to 1 over x cubed plus 1 times, what's the derivative of this? That's 3x squared plus 0. So this is equal to 3x squared over x cubed plus 1, which is equal to y prime. All right, so this is our final answer. Okay, now what if we're going to use another method with the use of u? So that's y is equal to ln u, where u is equal to x cubed plus 1. Okay, and y prime is equal to what? Y prime is 1 over u times the derivative of u. And here, the derivative of u, or u prime, is equal to 3x squared, correct? Here we go. So let's substitute 1 over u, which is x cubed plus 1, times u prime is 3x squared. So this is equal to 3x squared over x cubed plus 1. So we got the same answer. All right, this answer and this answer. So This is our method 2, and this is our method 1. Okay, so I hope you understood both methods so that you can do any of them. You can use this in method 2 for checking, actually. That's what I do when I wanted to check if my answer is correct. Okay, and number 4, so this is in a form of y is equal to logarithm of 2 plus sine x base 10. Sorry, base 10. But since it's base 10, sometimes we don't write the 10 anymore, okay? Because it's considered as 10. It's just like the index of square root, okay? So let's just refresh or recall the derivative of logarithm. Okay, let's say log x base a. So this is equal to y over, this is equal to a, sorry, x, the log a, oh, sorry. Or I can just log a base e, something like that, and x prime. Or this is equal to 1 over x ln a x prime. All right. So using logarithm and natural logarithm are actually the same as long as, or equal as long as the base of the logarithm is a, e. Okay, so let's now apply, oh, this is y prime. So let's now apply this rule here. So we have y prime is equal to 1 over, copy the x here, or the 2 plus sine x, all right? And also the natural logarithm of the base, which is 10, correct? And times the derivative of the x, which is the 2 plus sine x, 2 plus sine x prime, okay? So we have copy 1 over 2 plus sine x times the derivative of 2 plus sine x, that's 0. We have cosine x over 2 plus sine x ln 10. So this is our final answer, all right, for method 1. Now let's use method 2. So method 2, let me just copy the problem. The logarithm base 10, 2 plus sine x. Okay, so let y is equal to log u 10 and u is equal to 2 plus sine x. Okay, so what's the derivative of y? The derivative of y is 1 over u ln 10 times the derivative of u, right? And what's the derivative of u? Here, u prime is equal to 0 plus cosine x. I hope you still remember the derivatives of the trigonometric functions. So u prime is equal to cosine x. So let's substitute that here. We have cosine x over u is 2 plus sine x times the natural logarithm of 10. Okay, so let's check if we got the same answers. Cosine x, 2 plus sine x, of 2 plus sine x times ln 10. 2 plus sine x ln 10. Okay, we got the same answer. All right, so better if you knew this method such that you can check your answer. Okay, in example number 5, it says find the slope of the line tangent to the graph of y is equal to. Oh, I think this is 2. All right, this is 2. Of 3x plus 1 base 2 at x is equal to 1. So we're going to find the slope. To find the slope means to find the slope of the tangent line means find the derivative of x, f of x, or find the derivative of y. Diba? Okay, that's y prime. when x is equal to 1. Okay, since we're just looking for the tangent, then we can just take the derivative of y. So that's the slope of the tangent line is equal to, okay, y prime. And let's take the derivative of this. So let's say our problem is y is equal to log 3x plus 1 base 2. Let's say base 2. I think it's 2. Okay, so let's take the derivative of this. So this becomes 1 over 3x plus 1, the natural logarithm of 2 times 3x plus 1 prime. Okay, so we have, what's the derivative of this? That's 3x plus 1 natural logarithm of 2. So this is our MT, okay, or the slope of the tangent line. Now we want to know the specific slope of the tangent line when x is equal to 1. So that's M tangent 1 is equal to 3 over 3 times 1 plus 1 ln 2. Okay, so we have the slope of the tangent line is equal to 3 over 4 ln 2. Okay, or we can rewrite this or express this answer into 3 over ln 2 raised to 4 with the use of the property of natural logarithm. So 3 over the ln 16. So whichever answers you used, that's fine because they're all correct. All right. Okay, so that's how we solve number 5. Next, number, oh, yeah. So we have two number 5 problems here. Okay, so let's solve this number 5. So we're just going to get the derivative. So f prime. Oh, let me erase. There we go. So f of x is equal to x times the natural logarithm of 3x. Okay, and f prime of x is equal to, since the given function is a product of two factors or functions, so we can use the product rule. And the product rule is, let's say y is equal to uv, y prime is equal to u v prime plus v u prime. Okay, u prime. Okay, here we go. So let's apply that property or theorem here. So that's x. Oh, sorry. X. Let me just erase. There we go. So x times the derivative ln 3x, derivative of this plus ln 3x times the derivative of x. So let's apply x. What's the derivative of this? The derivative of that is 1 over 3x, okay, times the derivative of 3x plus L and 3x times the derivative of x is 1. And here, I can cancel out x here. So this is 1/3. What's the derivative of 3x? That's 3 plus ln 3x. So this is equal to cancel, 1 plus ln 3x. So this is our f prime of x. Okay? So that's how we solve this exponential and logarithmic functions. All right, and let's proceed. Oh, okay. So this is our next topic. We have chain rule involving trigonometric functions and inverse trigonometric functions. So before we proceed to this, I hope everything is clear when it comes to the derivatives of exponential and logarithmic functions. Okay, so please check our next part or the part 4 of our video.